Hello, algebra students. Mr. Lawrence here with a flipped lesson for you. I wasn't planning on doing this one, but I saw you having some difficulty with this, so I want to go over it one more time before we have the quiz, because this should be easy stuff. All right, we're going to consider how many times larger. Now we've got the 72 times 10 to the third. How many times larger is it than 8 times 10 to the negative second? Well, remember, this is a division problem, right? And we are going to divide 72 by 8, which of course is 9, right? And then we're going to do 10 to the third divided by 10 to the negative second. Now, a lot of you are getting in trouble because you're just trying to guess and you think you know the answer, but you don't. Remember that when we're dividing like bases, we subtract the exponents. Please write the subtraction problem down. The subtraction problem is 3 minus negative 2. And then that should trigger something in your memory. Oh, yeah, I'm supposed to cancel those out. 3 minus negative 2 is 5. Okay? So it's times 10 to the fifth. Now, usually with these kind of problems, I want you to give it in standard notation. So we're going to take the 9 and we're going to multiply it by 10 5 times. So 1, 2, 3, 4, and 5. And so it's 900,000 times larger. And I know that's hard to believe, but that's the actuality of it. Okay, so let's look at number 2 here. Um, I've got 7.2. It's essentially the same problem. I'm going to divide here just like I did. But since I had 72 divided by 8, and that turned out to be 9, now I have 7.2 divided by 8. Since I'm divided my numerator by 10, there's less to share with the 8 people. Well, that means I'm going to divide my answer by 10, right? Do you all agree that I divided by 10? Okay, and so I divided by 10. Why? You can think about it this way, the 9's in the numerator. I did it to the one numerator, I have to do it to the other. You could think about it that way. Okay, so the answer to the 7 and 2/10 divided by 8 is 0.9. Okay, and we're gonna go off on a tangent here and practice those a minute. How about 5.5 divided by 11? How about 6.3 divided by 9? How about 2.4 divided by 8? Let's see. Go ahead and pause the video. See if you can figure these out. Okay. If you're still watching, I hope you've paused the video and tried to figure them out. I'm going to tell you that I know that 55 divided by 11 is 5. Well, this must be 0.5. Yeah, it's that easy. 6.3. Well, 63 divided by 9 is 7. So this answer is 0.7. 2.4, well, 24 divided by 8 is 3. So this must be 0.3. And again, it's all in the numerator. If I want to write those over 1, that's fine. Okay, this was divided by 10 in the numerator. I had to divide by 10 in the numerator the answer on all 3 of them. Okay, so let's jump back to the problem. Now, of course, this part here is going to be easy. We've already done it. It's going to be times 10 to the 5th, right? And so then I'm going to multiply by 10 5 times. So there's 1, 2, 3, 4, and 5. So it's 90,000 times larger, which makes sense because this number here is 10 times bigger than this number. So my answer is 10 times bigger than this answer, the second answer. Okay. Now, how do we do it when it's 72 divided by 0.8? Well, I know that 72 divided by 8 is 9. But what's 72 divided by 0.8? Okay, so sorry about that. I got interrupted by a phone call. We've got 72 divided by 8 is 9. Now we have 72 divided by 0.8. Well, this time the denominator got divided by 10, right? Now, I'm not going to divide my answer by 10. I'm actually going to multiply it by 10. It's the inverse because it happened in the denominator. See here, I divided by 10, right? So in the numerator, I'm actually going to multiply by 10, okay, because it's not in the denominator. If you think about it this way, I'm dividing by a smaller number, which means everybody gets more, okay? So instead of getting 9, I'm getting 90. So I know that this part here is 90 times 10 to the 5th. And again, it's the same, so I don't have to rewrite. You know, I could, but I've already done it. I purposely made them the same so you could see that. So I'm going to take the 90 and multiply by 10 5 times. So there's 90. So there's multiply by 10 once, twice, 3 times, 4 times, 5 times. And it ends up being 9 million. Notice it'll be 10 times larger than the original blue answer. Okay, again, we're going to jump off on a tangent over here. And not really a tangent, but do some practice. Let's say we have 54, and we're going to divide it by 0.9. And let's do 63 divided by 0.7, and then let's do 18 divided by 0.6. Okay, well, 54 divided by 9 is 6, right? 54 divided by 9 is 6. My denominator got smaller, my numerator's got to get larger, that'll be 60. Okay, 63 divided by 7 is 9. This will be 90. And then 18 divided by 6 is 3. And so this will be 30. Okay? All right, I got to pause here and I got to go teach class, but I will be back with you shortly. Hey guys, it's been several hours since I started this video, so apologize if there's no continuity. I assumed I had gone off on that tangent that I mentioned and talked about some of those problems. So now let's go ahead and try some other ones. Now I would really love for you to go ahead and try this on your own. Okay, pause the video, try to do these two problems, and then see if you get it right. By the way, this is a 9 here, okay? If you can't read something, let me know. And remember, when I'm asking how many times greater, we're talking about division problems, right? Okay, so go ahead and pause the video, and then I'm going to try to figure out, when you unpause, you try to figure it out, and then unpause it when you're ready to see my solutions. Okay, so here come my solutions. Number 4, I know that 48 divided by 6 is 8. So 4 and 8/10 divided by 6 would be 0.8, right? So when I do this part of the problem, I'm going to get 8/10, right, times. Now when I do this part of the problem, remember I told you to write the subtraction problem. So I'm going to do -5, and then I'm going to do minus -7, right? Okay. Change the two negatives to a positive. Subtracting a negative is the same as adding a positive. And so my problem is really -5 plus 7. Well, that's a positive 2, isn't it? So I have times 10 to the second power. Now, when I'm thinking about scientific notation, or how many times greater, I like to give my answers in standard notation. So if I multiply by 100, that moves the decimal point like that, turning this number into 80. It's 80 times larger. All right, there we go. Here comes my solution for number 5. If you haven't tried number 5 yet, please do. Okay, I know I have to divide here, and I know that 36 divided by 6 is 6. 36 divided by 6/10, well, let's see here. I'm taking $36 and sharing it with 6 people. Now I've got the same amount of money and less people. My answer has to be more. Each person has to get more. Okay, so I'm going to get 60 in this case. So I'm going to have 60 for the decimal part times 10 to what power? Let's see here. Well, looks like I have a 9 minus a -1. 9 minus a -1 is addition. That would be the 10th power. All right, so 6.0 times 10 to the 11th power. And that's going to be a large number. I guess I didn't have to do this step, kind of did it automatically. But I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 600 billion times larger. Yeah, it's many times larger. Absolutely. Okay, what did I do here? Well, you know, I'm so trained to think, oh, this number's too big. It's not in scientific notation. I could have gone right to from this answer to 600 billion, but instead I went to scientific notation first. This was an unnecessary extra step. I would encourage you not to do it because it is an extra step. But if you do it on accident, well, you know, you're just like me, working a little too fast. Slow down a little bit. Okay, here's one more to try. Now, this is division, right? So I'm going to do 54 divided by 0.09. Well, I know that 54 divided by 9 is 6. I also know that 54 divided by 0.9 would be 60, right? What did I do? I divided by 10 here, so I had to multiply by 10 there, right? It's inverse because one's the numerator, one's the denominator. So then when I do this, 0.09, I'm going to have to get 600. So this part here is going to be 600. Okay, and now I'm going to do this part. I know I'm going to have times 10 to some power. I have a negative 2 minus a negative 5. Well, minus a negative is the same as adding a positive. This will equal 3 to the third power. So I have 600 times 10 again, and times one more 10. 600,000 times larger. Okay, now just for a couple special friends who are having a little trouble, I want to throw a couple more problems at you real quick. Okay, here's a couple extra problems I want to do. First of all, I want to talk about 3x to the fourth plus 2x to the fifth. Hopefully you know that these are not like terms, and therefore you can't add them together. They're not like terms. Okay, now the cool thing is on um, this problem here, I'm going to call it problem A, is they're not like terms. We've got a 10 to the fourth, and we've got a 10 to the fifth. But I can manipulate one of these numbers so that it looks like a like term with the other one, and I won't change its value, and therefore I'll be able to add it together. Well, remember I advise you to always change the smaller of the two exponents. So I want this to turn into a 5, so I'm going to multiply by a 10 to the first. Okay, but if I multiply by 10 to the first, I've changed the number, so I'm going to divide the decimal part of it, or the coefficient part, by 10 to the first. And so I'm going to get 2 times 10 to the fifth plus, and like Veronica was telling Tommy, line up your decimal points. This number here is going to turn into 0.3 times 10 to the fifth. And I'll put the decimal points in, I'll put some placeholders of zeros, and I'm ready to add. I'll get a 10 to the fifth, I'll get 3/10, and I'll get 2, and there we go. I'll make sure, of course, that my decimal here is, excuse me, is between 1 and 10, right? It can be equal to 1, but it cannot be equal to 10. Okay, problem number B, letter B, I guess I should say. Let's see here. Was that a song by the Beatles, letter B? Oh, wait, that was the Sesame Street Beatles, my mistake. Okay, same situation, subtraction, I need like terms. My advice is to change the smaller of the two exponents. Remember that negative 5 is smaller than negative 3. So I'm going to multiply this by a 10 squared. That'll turn that into a negative 3. And I'm going to divide by 10 squared, or 100. So my problem becomes 8.24 times 10 to the negative third. And then I'm going to subtract, and dividing by 100 is going to go like that. So I'm going to go 5 to 3, and then times 10 to the negative third. And now I can subtract. I like to put my zeros in as placeholders. Okay. Now, there's a couple ways to think about this. One is to borrow, and that's a great way to think about it. You could also think about it like this. Where's my shade? Oh, shade. We're not working. There we go. Okay. There we go. We're subtracting. You can think about 40 minus 23. You don't have to think about 3 from 0. 40 minus 23 would be 17, wouldn't it? Okay, and now I can get rid of my shade and continue the problem. Okay, now here I can think about 82 minus 5. So now I'm going to put my decimal point in, but 82, my shade is acting up, kind of like Elmo shade. All right, 82 minus 5, I believe would be 77. Okay, that's one good way to do it. Of course, it would be times 10 to the negative third. Okay, now for those of you who need to do it more traditionally, I will do it more traditionally. We've got 8.240 minus 0.523. Okay, and I'll do it the way with the borrowing. Don't have enough ones here, so I'll take 10 ones away from here, put them over there. So now I have 10 ones minus 3 ones is 7 ones. Here I have 3 tens minus 2 tens, or I'm sorry, these are thousands, excuse me, because I'm on the other side of decimal point. I'll get hundredths, 3 hundredths minus 2 hundredths is 1 hundredths. Now I don't have enough tenths to take away 5 from, so I'll borrow 10 tenths from there, right? And so I'll have 12 tenths minus 5 tenths is 7 tenths, and then 7 minus 0 is 7. And of course it's times 10 to the negative third. And notice I get the same answer. Okay, that's the video. That's for those of you that were having a little bit of trouble with this. We'll get a little practice Monday, and the quest will be Tuesday. All right, Mr. Lawrence signing off. Have a good night, everybody.